based on some conditions. We will start with case. So the case statement is actually used to create another column based on some conditions. So you already have some columns. Let's suppose there are 4 columns in the table. What you will do is you will create another column, the 5th column, based on some conditions. Okay. Let me start sharing my screen. Okay. Let's suppose you have a table called as student. Okay. So you have 4 different columns over here: student ID, name, marks, and attendance. Okay. So suppose you want to create another column called as grade, and that is dependent on your marks column. And the conditions for creating the grade column is, if suppose someone is getting more than 80, then they are getting A grade. If someone is getting between 60 to 80, then they are getting B. If someone is getting anything between 40 and 60, then they are getting C, or else they are failing. That means anyone who's scoring more than less than 40, then they fail. Okay. So based on these conditions, you have to create another column called as grade. So the way to do this is, I need let's suppose student column, and then I need a student name column, and then I need a marks, and then the grade, which I will create now. Now to create another column, you have to use a case. The way to write is case, and then the conditions. Okay, when marks is greater than equal to 80, then it should show A grade. Okay, so I'll put A inside quotes because A is a string. Okay, so putting it inside quotes. But if the marks is suppose greater than equal to 60 and marks is less than 80, then it is B grade. Okay, but when marks is suppose greater than equal to 40 and marks is less than C, then it is C grade. Okay, or else it is fail. So else fail. Okay. Now this is the conditions that you are given to create the grade column. So these are the conditions. But what should be the column name? That is something that we need to define at the end. So the way to define this is, after case, you have to write end as whatever column name you want. So the column name is grade. So this is not in quotes because this is not a data value. This is a column name. Okay. So you do not need to put this in quotes because this is a column name, not a data value. And lastly, as always, from where I have to pull this? From my student table. Okay. Students dot. Okay. Hold on. Okay. So what I've done is I've given, based on the marks, they have got the grades. So if suppose someone is getting more than 80, then they're getting A. Someone is getting between 60 and 80, like in the second case, this one, they are getting B grade. If someone is getting between 40 and 60, then they're getting C, or else they are failing. Now, the thing that you need to remember is you need to write the word case as a keyword. Then wherever you are wherever you are saying a condition, you have to write when. Okay. So when marks is greater than equal to 80, then A. Okay. There's a better way to write all this. Now, the way it actually, first of all, the way it runs is, suppose someone is getting 90. Okay. So the first condition, as soon as it encounters that, it will execute and it will showcase A grade. Okay. If suppose someone is getting 50. Okay. So is 50 greater than 80? No. It will go to second condition. Is 50 greater than equal to 60 and less than 80? No. Is 50 between 40 and 60? Yes. So it will execute this. So it will keep on checking till the time one of the condition becomes true. Okay. If suppose there is a condition, if none of the condition become true, then it will return null. Okay. Now, a better approach to write this is case when marks is greater than. this will also give the same result. Now, there is a difference in the condition that I put. To understand this, you need to understand that it actually follows sequential execution. That first this is executed, then this, then the third, then fourth. Now, what will happen over here? The same kind of execution. If suppose someone is getting 90, the first statement is true. Fine. It won't even go to the second one. Okay. Even though this statement is also true, if suppose someone is getting 90, then even this statement is also true, right? Because 90 is greater than 60. But this won't execute because the first one has already executed. Okay. If suppose someone is getting 50, then this statement is not true because 50 is not greater than equal to 80. 50 is not greater than equal to 60. This also won't execute. But 50 is greater than equal to 40, so this will execute and it will populate. Okay. Clear? Any doubt in this one?
So due to the sequential process, we do not need to proceed with AND statement.
Yeah, then you, I mean, do not assume that it cannot, you do not need to write AND. The thing is, you see, there are conditions on the same column. Okay, so that's why I'm not making use of the AND here in the second part. And in the second question, I'll make use of the AND. You have to make use of AND there actually. So let's suppose the second question is, if the marks is greater than equal to 80 and attendance is also there, right? The marks is greater than equal to 80 and attendance is greater than equal to 90, then high performer. Okay, let me write this down. Marks is greater than equal to 80 and attendance is suppose greater than equal to 90, then high performer. Okay. The second condition is if marks is greater than equal to 60, there's only one condition, okay, then average, else low. Okay, so these are the three conditions, or three values also: high performer, average, and low. Now here, same thing I'll do. Select student name, comma, marks, comma, attendance. Okay, comma, is when marks is greater than equal to 80 and attendance is greater than equal to 90, then high performer. Okay, so I made use of AND. There's no other approach because there are two different conditions on different columns. When marks is greater than equal to 60, then average, else low. So these are the three conditions. And from which table? From students table. Else low as well. And as right. Attendance value.
I think there is an extra spacing.
Extra spacing where?
When marks is greater than or equal to 80, in between that.
No, that's okay. That's okay. That doesn't matter actually. Okay. So now your grade is populated based on multiple conditions. In the first condition, you have two different subconditions, one on marks, another one on attendance. Both should be true. Second one is only based on marks, and last one is the leftover condition. Okay, so this is the way you write a basic case statement.
Rishabh, can we use case with joins? Like there are two tables and I want a condition based on two tables.
Yes, you can. One table is having only the student ID and the name, and the second table is having the student ID and the marks. So what I need is I need to find out the grade of every student. Sorry, student name and grade I want to know. That time you have to join and then use a case statement. Okay. For example, if suppose first table is having student ID and the name, and the second table is having the student ID and the marks, and I want to know the student name and the grade. Okay, so first of all, you need to join both these tables, get name and marks, and from there you have to find out the grade, created column, grade, and then based on the conditions you can populate. Let me know if there's any doubt, because the next one is a nested case. That would be a bit complex. But before that, any doubt in this one? Okay. Moving forward, let's talk about nested case. Okay. And for this, let's pick up some other table. Okay, so you have this table wherein you have the employee ID, name, department name, salary, and the rating. Okay. Now, the question here is the big question actually. If the department is engineering, okay, then if the rating is in engineering, if the rating is greater than equal to 4, then you have to showcase high performer. Okay. Else, you will showcase needs improvement. Okay. Whereas, if the department is HR, and in HR, suppose the rating is greater than equal to 3, then you will populate stable. Okay. Whereas, in all other cases, you will populate low. Okay. The third one, the sales. Okay. In this, if rating is greater than equal to 4, then you will showcase target achieved. Else, you will showcase underperformer. Okay. So there are different department and different values for each condition. Okay. So this is not like the previous one, where in the previous one there was a single condition and you were just populating a table, a column. Wherein based on the department values, then you're going a bit level deeper, and then based on ratings, you are trying to populate different things. So this is a case of nested case, wherein you are drilling down based on value. Okay. So now this is the way to do this is, again, we have EMT name, department, you have rating, okay, and then I'll start the case later. Now the first thing is if the department is engineering. So when department is equal to engineering. So one thing that you need to remember, like you will need to write these text statement as it is. I mean, do not change the case or anything. Okay. Then when the department is engineering, there are two things. If the rating is greater than equal to 4, or it is different from lesser than 4. Now here I will write another when statement, another case statement. Case when rating greater than equal to 4, then high performer. Okay. Else needs improvement. Okay. And this you are just ending. There is no column name. Do not confuse this with end as. Okay. This is simple end, because end as is given only at the end when you are writing the column name. Right now we are not done writing the column. We are not done writing the condition. So we are just ending this particular case. Okay. Now we have conditions for the department engineering is done. Now what we'll do? We'll go to HR. When department is equal to HR, then again case statement. Rating is greater than equal to 3, then stable. Okay. Else it is low. Again, I'll end this with a simple end. Nothing else, because I'm only done writing the conditions for HR, not done writing all the conditions. The last thing is with sales. When department is equal to sales, Okay. Then case rating is greater than equal to 4, then target achieved. Okay. Else under performer. Okay. So now we are done writing the conditions for sales, and we are even done writing the all the conditions. So we'll do end as, let's suppose the column name is category. Okay. And from where I have to put? From the table name is employee performance. Run this once. Rating rating greater than equal to 4, then case when this is in this category.
Category shouldn't be in a quoted this thing, right?
Oh yeah, sorry. Okay. So now based on which department they are and what rating they got, you have the category column populated. So wherever the is engineering and greater than 4, they are high performer. And then HR, wherever the rating is greater than equal to 3, then they are stable, else low, like in this case. In sales, if the rating is greater than equal to 4, then their target achieved, or else they underperform, like in this case. Okay. One thing to keep in mind, like when you have multiple condition like this, and as will come in not the only at the end when you are defining the column name. Okay. This end is only to showcase that this is the end of this case. There are other cases also after this. Okay. Just go through this once and then we'll try one question. Okay, let's go back and try one question. So you have this table. Now the thing that you guys need to try is, if the department is engineering and salary is greater than equal to, let's suppose 80,000, then you have to showcase high pay, else medium pay. Similarly, if department is HR and the salary is greater than equal to, let's suppose 45,000, then you have to showcase good pay. Okay, else low pay. Lastly, if you are in sales and the salary is greater than equal to 50,000, okay, then you have to show what should I suppose average pay. Okay. and else you have to show basic. So based on department and salary, you have to showcase, you have to build a column that will be based on these conditions. Try doing this one. It's similar to what you've done just now. Okay. So yeah, others. Good. Like, got a couple of responses. Okay. Yes. Yeah. Invoice. So this is one such response. So when I run this, case when engineering comma was missing. Okay, so now this is the right one. Okay, so what you've done is you have picked the first condition, that is for engineering, and then inside that you wrote multiple cases. Once you're done, you wrote end just to conclude the engineering case. Then you started another one when department is equal to HR, wrote the HR conditions, again ended with end, then that sales, and you are ending it with end. So it's the same thing followed over here as well. Okay. Any doubt in case statement? Yeah.
So the first, I'm just trying to understand the syntax. We have on line number 188, we have added a case, and then we are placing base scenario, and then we are nesting it. So on line number 193 and 198, we don't require the case that we
Okay.
used on 188?
Okay, yeah. For that you need to see this more. So see here also, when I'm writing case only once. In the second condition, I'm not writing that word case again.
Oh, okay. Right. So that's the main case, and
Right.
then we have multiple scenarios where we don't need that. Okay.
Give me a minute, I'll be back. There's someone door. I'll be back. Okay. Let's move to the next topic, and that is your union and union all. And let's suppose I have this table. Let's start from online orders. And this has 4 records. The column names are order ID, customer name, and your amount. Okay. And then you have another table, what is called as store orders. It's exactly the same. Okay, that's the number of records that's different. So in the first one, you have 4 records, and then actually both have 4 records. Okay. So one thing which we forgot to mention here is the order ID is 1, 2, 3, 4. Okay. Order ID is having value 1, 2, 3, and 4. Whereas if you look at store orders, it has 3, 4, 5, 6. Now, union and union all is actually used to append one table below the another. Okay, they're used to append one table below the other. Okay? Like in this case, if I want to create one table by combining or appending these 2 tables, the way to do this is, select star from online order, union, select star from store orders. Okay, and for the sake of simplicity, I'm just ordering it so that the order by order ID it becomes easier to read. Okay, so what it has done is it has appended both the tables, but one thing to notice here is it has removed the duplicate records. For here, see the order ID 3 and 4, here also order ID 3 and 4. So ideally they should have came in twice, but it is getting showed up only once. Okay, so what it has done is it has removed those duplicate records, and that is the difference between union and union all. Union will remove the duplicate records, whereas union all will not remove the duplicate records. It will keep the duplicate records as it is, like in this case. Okay. Now, couple of things to remember here in union all. Whenever you are doing this union all usage, it's a column by column appending. Okay, so you need to make sure that the columns are in the same order. For example, if online orders, I have order ID, customer name, and the amount. But in the store order, I have customer name, then order ID, then amount. Even if you append, it won't make any sense. Okay, because the order ID will get appended to customer name, which is incorrect. Okay. And the second thing is the data type should match. You cannot append a string with a numerical value. That is incorrect. Okay. So two things to remember: the order of columns that is there in the table should be same, and the data type should also match. Only then this will make some sense. Otherwise, it won't result in anything, any right values. Okay.
So both the tables should have the same number of columns and same.
If let's suppose there is another column here called as location. Okay, and here in online order I do not have any other column. There's just 3 columns. So now when you append it, what will happen is location column will be created, but all the values which are coming from online orders would have null location values.
Right. Okay.
Okay, so that will still run, but all the values which are coming from the online orders will have null location values.
One more thing. So we said the order of column should be same. So in case location is before amount, then also it would create issues.
Yes.
Amount would get appended inside.
Correct. Amount, location and amount will get appended.
Okay.
So that's why order of the columns is very important if you are using union all.
Okay. And is there a like precedence of first table or second table mentioned like
the table which you mentioned first in union will be, those values will be there first.
Okay. Yeah. Okay. Thank you.
Any other question? Any other question till now? Because the next one is your subqueries. Before that, anything important? Anything till here?
Have you shared this like schema or data with us so that we can?
Actually, this thing is, I mean, everything is on my system.
Okay.
I mean, it's local host, so you won't be able to access from here. But if you want, I can give you a create table and insert table command for the tables. I mean, these are basic tables that you can use.
Right. If you can share that script with us, so we can also.
Yeah, I'll share it towards the end of the session.
Right. And just one more query. Are you using Mac here?
Yeah, I'm using MacBook.
So I'm also using Mac, but for me, the PG Admin 4 application is very slow. Like it responds after 2-3 seconds for me. Yeah.
I generally do not close any of the sessions, any of the applications. So in my MacBook, you will see, I mean, 50, 60 tabs open at any point of time. But I know this is slow. I mean, PG Admin is a bit slow. Sometimes I use this Google BigQuery also. I have my own project over there. So, but I generally do not recommend because people generally forget to check the usage. So I have the paid version there. So if you have the habit of checking your usage, then you can make use of that. That is very fast. But that has a risk of over usage if you're not checking it.
So is it also slow for you? I think it's.
If I close this, then it will be slow. I generally do not close this.
Also, Gaurav, you have to check whether the application is for Apple architecture or Intel architecture. That was an issue for me. I think I and Arun solved it on the last when we were installing it.
Okay. And how did you fix it? Like, did you download a separate DMG?
Yeah, we did.
Okay. I'll also try.
If you're using a MacBook, you generally do not need to close this after the sessions. Because MacBooks are designed to handle a lot of tabs here.
Right. Okay.
I generally do not close this. This is open for months, I believe.
Okay. Yeah. Okay. Thank you.
Any other question? Because the subquery one would be tricky. Before that, I want to understand if there's anything that needs to be discussed. Moving forward, let's go to subquery. Okay, hold on, guys. I just to save this table. Let me check the table name. Wait, I do not remember. Okay. Now, this is one simple table where you have the employee ID, employee name, department ID, and salary. Okay. Now I want to know those employees who earn more than the average salary. Okay. Who earn more than the average salary. Now, this question is a typical subquery problem. In a subquery, you will have two different parts. One would be the inner query, and the second one would be the outer query. An outer query will take an inner query as input. For example, till now, what you're saying, select star anything from a table name. Okay. Herein, you do not need to pull in from any table. Okay. Or even if you are pulling from table, your conditions are such that it is based on some other thing which is not directly available in the table. Like in this problem, the question is you need to find out those employees who earn more than the average salary. So if I look into this, there are two problems here. First of all, at this point of time, I do not know what is the average salary. Okay. The second problem is I need to find out those employees who earn more than this average salary. Now, this could be solved in two steps. Okay. In the first step, what I'll do, I'll find out the average salary. Select AVG salary from employees. Okay. So this will give me the first sub problem. What is this salary column name? Okay. So this is my average salary. Now I need to find out those people who are more than this number. Okay. So this becomes my inner query because this gives me the one part of the problem, that is the average salary. So what I'll do, I'll put this inside bracket. This is my first sub problem. And this is my inner query. The outer query becomes something like this. Select EMP name, salary from employee. I need those people who are earning more than this. So what I'll do, where salary is greater than this, whatever I'm getting from here. Okay. So I'll get only those people who earn more than this 56,666 rupees. Okay. In a sub problem, in a subquery approach, there are two problems that you will need to solve, and there are two queries that you will need to write. One would be your inner query. In our case, this is this one, wherein you are trying to find out the average salary, The second query is the outer query, this one, wherein you are trying to calculate or compare this something from the table from whatever you got from the inner query. Okay, so once you the compiler thinks it will have to execute this one first, the innermost query first, and then the outermost query. Okay, let's take another simple example. Okay, there's another department one. Okay, fine. So you have a table called as this one, employees one, wherein you have EMP ID, you have EMP name, you have department ID, and you have salary. Okay. Then you have a department table, this one, wherein you have DPT ID, that's the department ID, and the DPT name. Okay. So I want to find out those employees who belong to the engineering department. Okay. So this information of engineering is not readily available in the employees table. Employee table has only the department ID. It does not have the department name. Okay. But from this table, the department table, you can say the engineering department has department ID 1. Okay. Now, again, there are two problems here. The first problem, at this point of time, I do not know what is the department ID of the engineering department. Okay. That's the innermost query. And the outermost query is I need to find out those employees who belong to this department ID. Okay. The first problem is to find out the department ID of the engineering department. And the second problem is to find out those employees who belong to this department ID. First of all, let's solve the innermost query. Let's find out the department ID of engineering department. So select DPT ID from departments 1, where DPT name is equal to engineers. Okay, so this will give me the department ID of the department engineering. From departments. Okay, so it gave me 1. Now I know what is the department ID of department engineering. Okay, now I know this. Now what I do is I need to find out those people who belong to this department. So what I do, select EMP name from employees 1, where DPT ID is equal to whatever I get from this. Okay, whatever I get from this, I'll get. So Aman and Veena are the two people who belong to this department. Okay. Clear?
So we are sure that this department ID would return a single record.
Okay. If you are thinking that it may return multiple records, then you should not use equal to. Equal to is only when you are using, if you know that there is only one value it will return. If you know there are multiple values returning, use n.
In, okay, yeah. Okay.
Okay.
Yes.
Let me know if there's any question. These are basic usage of your subquery. Any doubt here? Okay, so correlated subquery you may have heard. It's nothing but the subquery is running for each row of the outer query. Okay, and this is actually already done. I'll tell you where. Wage average salary is greater than this. So you're comparing this row by row. So it's actually running for every record. So you're comparing every record salary with the average. So it is running for every record. So it is a correlated subquery. Let's do one or two more simple topics. Then we'll jump to questions involving subquery as well. But let's do one thing. Hold on. So this is your employee ID and this. Okay. Now you have department ID and this is employee ID name, department ID and the salary. And in the department table, you have department ID and the name. Okay. So you need to find out those employees who are earning more than the department average. Earlier it was just average. Okay. Here, if you see, you are taking the whole table and calculating the average, right? I don't want that. I want the they should be compared with the department average. So for example, Aman and Bina, they both are in the same department. So the average of these two is 80,000, 90,000 plus 70,000 divided by 2. You need to find out those employees who are earning more than the department average. So in this case, only Aman will be the output. Okay. In this case, Chetan and Deepa, I think the average is 45, so Chetan will be the output. Okay. Now this is different from one you have done earlier. So this is not a table average. This is a department-wise average. Okay. So what I'll do is I need the EMP name and salary from employees 1E, where E dot salary is greater than select AVJ CD salary from employees 1, where DEPT ID is equal to E dot DEPT ID. Okay, so what I'm saying is wherever the departments are same, join it and you'll find out the average salary. And based on that average salary, just try to figure out which employees have like higher salary than their department average. So if you run this one, okay. So these are the people who are earning more than their department average. So it's actually both outer query and inner query are totally related here. You are using the department E dot department ID from the top one, okay, because here you have declared the aliasing, and then you are using calculating the average salary for every department. Actually, this question could be easily solved using CTE. So I'm not taught that yet, so I'm not going to that mode. But then this is actually easily solvable using your CTE approach. Okay. Okay, let's try one question. So you have this table wherein you have this thing. Okay, I want you to try and find out the name of the department. You need to find out the name of the department which has the highest salary. Do not go into try solving using subquery. Without subquery also you can solve it, but try solving using subquery approach. You need to find out the department which has the highest salary. So I want to find out the department name. Okay. You need to find out the department which has the highest salary. Yeah. So the question is, you need to find out the department name which has the highest salary. Which has the highest salary. Okay. Good. Others?
Usually the joins are more efficient or nested queries, like if we are seeing
Okay.
one
So
way.
there's no right one way answer for it. See, subquery, I'll tell you the good thing and the bad thing about subquery. So in subquery, what do you call, good thing is that whenever you are running the query, it is not like it is storing some data, right? It is actually continuously running. So it actually pulls out the data from the inner query and pushes it to the outer query. So there is no storing of the data. So your memory utilization is low. Once you reach a stage wherein you are writing long queries, 2000, 3000 line codes, that time you realize that this memory utilization plays a major role. But the bad thing is that you have to write each and everything over and over again. For example, if you are using average salary at multiple places in your code, every time you have to write this.
Hmm.
So that actually makes it difficult to read. Okay. And that's why everyone has came up with an approach called CTE. CTE also has an advantage and disadvantage. We'll discuss that later. Now coming to your joins. Joins again, it is actually how you're making use of joins. Many times what people do is that they are joining the tables and then they are putting the filter conditions. Even though there's a chance to put the filter condition before joining. That's why it is said wherever possible, you guys have to put the filter condition before the joins happen, because that time you will reduce the number of rows that are joining. Right. So there's no clear cut, I'll say one way approach to which one is better. It depends on what, I mean, what is working, what is not working that point of time. If you say that you have a condition wherein you put the filter condition before the join, please go ahead and do that. That will reduce the complexity and improve the performance of the code.
So right now, the scenario that we are discussing, is it possible to place a condition before the join that, let's say, Prem has responded in the chat?
Okay, let me see this. Okay, first of all, Prem, I was actually, okay, no, so select max salary is equal to, I'll take this because there is no way I could put the joining condition before the, so I'll put this where clause before the joining condition. I cannot do that.
Right. Okay. So wherever possible,
Wherever possible, you have to do that. You should be doing, because right now the data size is very small, so you won't feel any difference in the speed thing. But once you start working with millions of records, that time you have to do this.
Right. Okay. Yeah. Thank you.
Okay, so I've seen the responses. I think everyone is on the right track. Just one approach that is there in the chat is this one, wherein you are trying to find out the select. Okay, whoever was this is not correct. Select salary from employees, order by salary descending, limit 1. Now it is fine. What is the from? Okay, this one is not correct. Sorry. Who was this? I mean, I forgot to check the name because the salary column is not there in the department table. So like DPT ID is equal to where salary is equal to. Oh my god, Darshan, you have gone inside the subquery also.
Yeah, I mean, I just thought like, how do I get the max salary? Because where condition directly I couldn't do any max for it, right?
I mean, although this may just give you the right answer, but no, I won't. So, I mean, there are better approaches. You are going inside subquery again. You are writing one more query. I mean, you're overcomplicating, I believe. But let me check what the others have written and see. From the department ID is equal to find. Archana, you have gone in totally tangential way. You are comparing it with the average salary, not needed. Where department ID is equal to fine. For him, I think. Okay. So like max salary is matching with the salary code. So
do we have to write this select max query, or can we directly write like max where salary equals to max salary?
no, you cannot write like that.
Okay.
Department one does not exist. What is the table name that I'm using? Departments. Okay. Okay. So D dot DPTLE. So max salary from employees 1. Okay, so the person in this department is having the highest salary. So what you have done is you find out the maximum salary. Okay, you figure out the maximum salary, and then you're joining employees table and the department table, and comparing the salary with that max salary. Wherever it is equal, you're pulling in the department ID and the department name. Good. Try one more thing. Same tables, okay? Wait a minute, yeah. I want to know the second highest salary in this table. Second highest, okay? Not the top two. Top two is different. Top two means rank 1 and rank 2. Second highest. So I need only the rank 2. Using the same subquery approach. We need to find out the second highest salary. Good. Good. So I've got a couple of responses. I need the salary, employee ID and the salary, what they're earning. Okay, this is fine. By calculating the max salary and then checking which salaries are lesser than the max salary. So suppose there is salary of in the order 1, 2, 3, 4, 5. So you are checking which all salaries are lesser than the highest salary. In that, whatever is left, you're trying to find out the max. So that will give you the second highest. Good. Okay, let's jump to other questions. Max salary from. Okay, try this one. Need to find out whether retail company achieve the highest profitability in the North American continent. Okay, we need to find out which company has achieved the highest profitability within the North American continent. So there are multiple continents mentioned. We need to find out which company has achieved the highest profit in the North American continent. So the continent has to be North America and has to be the highest profit.
Also, the sector, does it have to be retail? Because I think in the question it's mentioned retail.
The retail company. So sector has to be retail.
Okay, yeah, change the question.
Others. Okay, so what you have to do is you have to equate profit with the maximum profits from the table where the continent is North America and the sector is retail. Think that, and they need the company and the country. Fine, I think that should be fine. Yeah. Okay, so just calculate the maximum profit from the table where continent is North America and sector is retail. Okay, let's try something else. Try this one. Customer purchase analysis for Flipkart. How the customer utilizing the report shows the number of unique products purchased by customer during this period, January to March. It will display the number of unique products as historical. Okay, fine. So it's more like how many unique products people have bought. So there's one unique product someone has bought. That is one. So for example, if I look into this explanation, customer one, Alice Johnson, has purchased two unique products. So Alice Johnson is customer ID 1, and this person has purchased two unique products with the product ID 101 and 102. Okay. Bob, this person has also purchased two unique products. Customer ID is 2. This person has purchased two unique products. Okay. So that means count of people who are buying two unique product is 2. And there is only one person, that is customer ID 3. This person has purchased one unique product. So this is the output that you get. The count of people have purchasing one unique product is 1. Count of people purchasing two unique product is 2. This is what you need to create.
I have a query regarding the previous question.
Mhm.
So I tried with and condition on different cases, right? Like where clause we have put it with if we put all the conditions in and like profit equals to select max profit from the table,
Mhm.
and continent equals to North America, and segment sector equals to retail. Would that work? It's not working for me. It shows no.
It won't. I'll tell you the difference. See, here what you're showing is you're calculating the maximum profit only after applying the criteria that continent is North American, sector is retail. Okay, so suppose you had 100 rows. In 100 rows, 50 rows had North America as continent, and 30 rows had North America and retail as filter. Okay, so you're calculating max profit from those 30 rows. Okay. Now, if I calculate from here, from the total, then you are trying to calculate the max profit from the whole 100 rows. So, so that is the difference. The question is achieve the highest profitability within the North American continent, and it is a retail company. So you have to put the filters and then calculate the max profit. So your approach is different. You are trying to calculate from whole table, but the question says you have to find out the maximum profit from those 30 rows.
Right. So and if I reorder my condition, let's say right now on line number 5 we have put in where condition, right? And if I place the condition where continent equals to North America and sector equals to retail before finding out the profits, would that work, or would that also not work?
That will also not work. So it's not like the condition which is applied first will be. It's not like if you're writing a condition first, that will be applied first, and then the second one. So all the conditions will be applied at the same time.
Okay. Yeah, got it. Okay. Thank you.
What was the question? Yeah, this one. Sorry. Try this one. Hold on, guys. I mean, this question is, can we solve using CT subquery? I'm doubting. Get this one. It could easily be solved using CTs. There. Try this one. Difference between the highest salary in the marketing and the engineering department. So the difference, there's only one output, that is your difference. There's nothing else. You may or may not use subqueries here. There's only one number, that's the difference between the highest salaries. So, okay, for this question, it's actually a bit straightforward. You don't even need a lot of things here. So what I'll do, select max of salary from DB employee table, where uh, from DB, sorry, join your DB department table on this is, suppose this is E, this is your D on E dot ID is E dot department ID is equal to D dot ID. Okay, where depart, department is equal to marketing. So this will give me the highest salary for the marketing department. Okay, and then simply I'll just subtract this. Okay, with the engineering department maximum salary. Okay, the difference. Okay. When to go to engineering, like max salary from department, join DB department. So
I think you should use semicolon at the end of first page.
what is the issue here? Well, okay, so this is not taking these brackets, which is surprising. It's just nothing in. Okay, fine, no problem. Okay, one more thing. The absolute of this. Now it has to work. This is a place wherein this. Zero. Okay, I did not change this. Fine. So what So what I've done is I've calculated the maximum salary in marketing and the maximum salary in engineering, subtracted those two, and then do a select ABS. ABS is nothing but absolute. So even if the difference is coming as negative, it will still showing as positive. Okay, that's the only thing, because the question also says the same thing, absolute difference. I've used ABS. Okay. Let me know if there's any question.
Yes, can you check my query for the previous question? It is showing multiple tables, but it should one only. The first one which is showing is correct, but there are multiple tables after
This-
this, which is
this-
all wrong.
This is for which one? The Flipkart one?
Just the question you sent about the last one at 3:37 p.m.
337. Yeah, this one actually, I don't know why it is tagged as subquery. This could easily be solved using your CT approach. That's why I asked you to just hold on to this question. Actually, I would be covering this question also, but using CTs. Using subquery, whatever you're doing, it's not correct. There are cases that you have missed. So that's why I said we'll use search CT to solve this. Just hold on to this question. We'll cover this in the next session. But we won't use subquery. We would be using CTs.
Okay, got it.
Any other question? So the next session would be actually around your CTs, recursive CTs, and the window functions, which actually is a very important part in SQL. Whenever you're going to any kind of interviews, there would be questions around window functions. How to import it or start querying. Okay, yeah. Nishant, Nishant, I would be covering this in tomorrow's KSR, and that will be for everyone.
Okay,
Because in tomorrow's KSR, I would be discussing about that IPL case. So I would be first of all showing how to use the create table command, and then from there how to import the table. I would be covering in detail in tomorrow's KSR.
Thank you.
Okay, what I'll do, I'll start the polls and let me know if you guys have any questions. If you guys have polled and do not have any questions, you can feel free to drop off.